Now in mathematics, we often look at sets of numbers. They're one of the more common types of sets, although sets can contain anything, as long as it's well defined. Here I've got a list of sets that we're going to be working with throughout this course, and it's not all of the sets of numbers, it's just a few of them that I want you to be familiar with. First of all, the set of natural numbers. Now I'm going to write these out. Some of them may be in roster form, some in set notation or set builder notation. I just want to give a definition to each of these sets. So the natural numbers are all of the numbers starting at the number 1 and increasing by 1 indefinitely. Okay, so the natural numbers would be the set 1, 2, 3, 4, 5, and so on. Now this is an appropriate use of the ellipse, meaning that you've established a very specific pattern of increasing by 1 that can be seen clearly. There's no other possible pattern here. And the ellipse shows that it continues on without end. Okay? So this would be the set of natural numbers. The set of whole numbers is essentially the same set, just with the number 0 included. Okay? So the set of whole numbers, 0, 1, 2, 3, 4, and so on. Okay? In fact, really the whole numbers are really just the natural numbers with one additional number. The set of integers are going to be all of the natural numbers and their opposites in addition to the number 0. Okay? So the integers really have, they really go in both directions. They go in the greater direction and in the lesser direction. So I would actually put an ellipse on both sides of this one. Put an ellipse on the left showing the negative numbers, and then say maybe -4, -3, -2, -1, 0. Those are the negative side, that's 0. And you tend to put these in order so that the pattern is clear. Then 1, 2, 3, 4, and then another ellipse or ellipsis. Some people call it different things, but and there you go. Okay, so you have one on the left, one on the right to show that these lists extend indefinitely in both directions. And it shows the integers then have all the positive natural numbers, the negative ones, and 0. The even numbers, well, even numbers, you could list these off a couple different ways. One of them, the roster notation, would just be to list off 0, 2, 4, 6, but actually even numbers you could also include, well no, I guess we'll just go with that. We'll go with the positive side, or yeah. So 0, 2, 4, 6, 8, and so on. And that would be what we call the roster notation. Or equivalently, you could do a set builder notation where you put a variable in for the number. Let's call it x. I like x a lot for variables or symbols. And some description. You could say that x equals 2n, where n is a whole number. Okay, where n is a whole number. So if you double any whole number, you're going to get an even number, right? So that's a mathematical description of an even number. We could look at odd numbers. Odd numbers being 1, 3, 5, 7, and so on. Or again, in set builder notation, you could write that as x such that x is equal to 2n. If we go with whole numbers, it would be 2n plus 1. If we went with natural numbers, it would be 2n minus 1. You'd have to shift things around a little bit. But if I go with 2n plus 1, where n is a whole number, And what you're doing is you're creating an even number by doubling it, right? So you take a whole number, like the number 0, you double it, 2 times 0 is 0, add 1, that gives you an odd, okay? In fact, that gives you the first odd. Then you take 1, 2 times 1 is 2, add 1, you get 3. For any whole number, if you plug it in, if I take the number 4, plug it in, double it, I get 8, add 1, I get 9. And so this is a very well-defined and specific way to create odd numbers. You can also do 2n minus 1, where n is a natural number. And that will give you the exact same set. It's a slightly different definition because you're starting with a different number. You're starting with 1, you double it to get 2, and then subtract 1, and you get 1 back, and that gives you the first number. So in order to get 1 as your first number and not -1 or something, you've got to get the proper consistent definition, right? So 2n plus 1 for whole numbers, 2n minus 1 for natural numbers, just depends on what you're plugging in. And then of course positive numbers. Well, positive numbers, unfortunately the roster notation doesn't even work for positive numbers. There's no way to list them, even to give a pattern, because positive numbers include decimals and fractions and whole numbers and everything else that are, natural numbers I mean, everything else that's greater than 0, and there's no possible way to list them off or to even list enough of them to establish a pattern. And so this set really requires the set builder notation. It's the only way to represent it in a well-defined way. To do this with set builder notation, positive numbers. I'll use the letter P for positive. So they're going to be the set of all P's such that P is greater than 0. Well, that's actually pretty simple. It's all numbers P such that that number is greater than 0. In fact, the definition of a positive number is every number greater than 0. All right, so as long as it's greater than 0, you've got a positive number. It's well defined because I can specifically identify every number and categorize it either in this set or out of this set, right? The number 5/3 is in this set. The number -21 is not in this set. The number 0 is not in this set, okay? So we can very clearly describe or identify every number as being in or out of this set. That makes this well defined, all right? Okay, so anyway, that gives you an overview of a handful of numerical sets that we'll be looking at. Again, there are many other numerical sets that we'll see, but this just gives you kind of an overview of some of the basic ones.